using iteration to work out numerical solutions to equations. So we want to solve this equation, so first step, rearrange to make the whole thing equal to 0, like so. So if I rewrite this as an equation of a curve and then sketch that curve, we get this, and then we see that one of the roots is here, and there are two further roots. So the root here lies in the interval between x equals 2 and x equals 3, and you've already seen this example in the previous video for the sign change method. And we have when x equals 2, y equals -1, negative y value. When x equals 3, y equals 1, positive y value. There's a sign change in the y values here, so there's a root in between x equals 2 and x equals 3. And here is the same working out, just using function notation. And to work out the value of x here, so the actual roots here, here and here, we use a process called iteration. So f of x equals 0, so here's my function equal to 0. I've taken all the terms to one side, which was our first step. We make x the subject, and that sounds a bit odd because there's x here, here and here. So which one do we make the subject? Well, we can do all of them. We can do this one, so I need to rearrange to make that x there the subject and all the other terms on the other side, or I can make the x here the subject, so all the other terms need to go to the other side of the equation, or I can make this x the subject. Okay, so for this one here, if we move these three terms to the other side and then cube root, we have x as the subject. In this one here, rearranging again to make that x the subject, and then the last one doing something similar. Now the x, which is on the left hand side in each of these equations, we have to replace it with x sub n plus 1. The n plus 1 is a subscript. Okay, so that's done. We now replace every instance of x on the right hand side of each equation with x sub n, like this. And these are called our iteration formulae. And the way they work is you start off with some initial value, either it's given or you use one of the intervals from your sign change method. You substitute that value into the right hand side of any of these equations, and what comes out is what's on the left. Then whatever comes out, you put it back into the right hand side. You calculate again, whatever comes out is on the left. Whatever comes out again, you put back in again, and round you go. Yeah, that's the iteration process. And you might find that depending on your initial value that you start with and the formula that you've selected, you work out one of the roots that you've seen on this graph. Or you might find your solution doesn't converge to any of these solutions, and you get either something nonsense or something that's undefined, and so on. But that's the nature of numerical methods. So if something doesn't work, so if you tried this iteration formula and you got nowhere with it, you try this one. If that doesn't work, you try this one. You try different initial values. So we're going to try some of that next. Okay, so I'm going to start with an initial value, x1 is equal to 3. And I'm using this iteration formula. I'll come back to these two later. So I'm going to start with x1 equals 3, that's my initial value. Here's the iteration formula that I'm going to use. So we start with n equals 1, we substitute that into here, and we've got this formula. Now x1 is 3, that's the initial value. And what comes out from this will be x2. So from our calculator, x2 is this value. Okay, so now n is equal to 2. This is the second step of the iteration now. And if I put 2 in here, then that becomes 2 plus 1, which is 3. So to work out the right hand side here, I need the x2 value, which is this. Now I don't want to type all this into the calculator, so we actually use the answer function. because each time whatever comes out the formula, we put the same value back in again, and the answer function on the calculator is ideal for doing so. Okay, so here's a quick version of what I just did. So the starting value is 3, put 3 in, press equals. That is now stored in the answer function. Okay, enter your iteration formula, replacing xn with the answer function. So if that's x1, then this is x2, and you need to write all of these down. Then press equals again, that's x3. I've written that one down. Then press equals again, that's x4, 5, 6, and x23 is about 2.80, and I'll just show you on the calculator. If you just press equals many times, you can see the sequence there of numbers is converging towards 2.802 something. So I can say that x is equal to 2.80 to 2 decimal places. Now if I take this value and I substitute this back into the original equation, which is here, my calculator gives me minus 0.008. I was expecting 0, but the value here is rounded, so that's a good solution. Yeah, I have found one of the roots correct to 2 decimal places. So I used the initial value as x equals 3 for this. What about if I change the initial value? So this time my initial value is 2. So if I press 2 equals, it's now stored in the answer function. So I've still got that formula in there. Ignore the value here, the 2.80 that was from before. So that's x2, 3, 4, 5, 6, 7, 8, 9, 10, and after many iterations we can see the solution is converging towards 2.80 again. Okay, so I have not found the other two roots. I have found this root again. Okay, so it's time to try one of the other iteration formulae. So I'm going to try these initial values with these formulae. So let's start off with the one in the middle. This one we've already used, so ignore that one now. So x1 is 1, so 1 equals, that's now stored in the answer function. Okay, I've just entered this formula using the answer function to replace the xn terms. So if x1 is 1, then x2 is this value, and x3, 4, 5, 6, 7, and after a number of iterations we can see that this value of x is corresponding to this root. It's about 1.4 something. So we have found the second root as well. And the more iterations we do, the closer we get to the actual solution. It's about 1.45 to 2 decimal places. And then moving on to this iteration formula with this starting value, this minus 1 here, that's my starting value now. So I need to enter minus 1, press equals, it's now stored in the answer function. Now we enter our iteration formula, and then we press equals a number of times on the calculator. These should be written down actually, but there's so many of them. It's no point writing them all down here. In the exam or in proper structured questions, they'll give you examples where maybe on the 4th or 5th iteration you can confidently round your answer to something that's a root to the given problem. So I have got minus 0.25 for this value. So we have found all 3 roots using iteration, and none of them were found using any algebraic method. We have used only numerical methods.